Good morning, everyone. And today is November 2nd, 2019. And this is the John Chappell Natural Philosophy Science Chat. So, we're just waiting for some people to show up in the science chat. And I just sent out an email message. But while we're waiting for that, I will just make some comments. So I did get some additional feedback from Gary from his YouTube channel about the nature of light. And the basis of the controversy here is whether light is some kind of photon, which in his word is kind of like a clump. And unfortunately, I don't have a nice whiteboard like he does, so I have Post-its, so maybe I'll try that. So, the question is between these two models here. So, Gary thinks that, light comes in these clumps and the frequency is determined by the space between those clumps, and these things travel as individual entities, so like particles, and they don't require any intervening medium to do that. So versus a wave conception where you do have some sort of medium and it's becoming either more compressed or more rarefied, similar to what we understand sound waves for. Okay, so the question here is, which one is it? I mean, it can't be both. And the purpose of science, hopefully, is to determine what the actual nature of the truth is on this. So it becomes a question of, well, how can you balance these two things and determine whether which one is correct, okay? Now, Gary, he prefers this individual clump theory because, it kind of appeals to our intuitions that, if we have some particle or something like that can travel through space. So just like this Lego brick, it can travel through space, and that's like a light wave. Light wave can travel through space, and it does not need any medium or whatever to do that. So he feels that that's simpler. Now, I would agree with that. I would say that all phenomenon that we observe does actually have to do with some particle traveling from point A to point B, and that if you have an interaction, it is because there are particles present. Right? Now, the problem with that particular theory, so I'm going to just list up a few of these problems here. So we had already discussed the problems that light does not seem to act as a particle in the sense that it, generally speaking, doesn't collide. So does this theory explain non-collision? So that would be one of our checkpoints here. All right. So we have, Gary or Franklin. Let's maybe just put a check, yes or no. And the problem there was that if light is truly, these two particles, similar to how these two Lego bricks are, that if I put two beams going in two directions, they're going to hit, and one of the main particles is that they collide and they cause them to be directed or, reflected in different directions. So they'll scatter, right? Now, so this can be explained in a number of different ways. I mean, it could be these things are so small that the chance of these things actually colliding is like almost zero, all right? Okay, well, I suppose that would be a possibility, but this is kind of getting into the realm of, it's still, I mean, because the interaction appears to be not almost zero, but actually zero, right? There's no interaction at all. And so we're kind of getting these kind of explanations, which sure, it could be true, but it's kind of hard to believe that it would be true, right? Versus if the light were, say, a wave, then we know, maybe we can demonstrate this in, say, a wave pool, that you can have a wave come in this direction, you can have a wave come in that direction. They don't interfere because the actual particles which are in your medium here have like two degrees of axes, right? And the particle, like, if you've got two waves coming at 90-degree channels like that, okay? So the one coming from this side will cause the particle wave this way. The one that's coming this way cause particle wave that way. And since the particle can move around like this, it can go ahead and transmit both of those at the same time. So that's what Gary is trying to ask. How is it that the wave theory can explain the non-collision of light beams, right? And that's how I would explain it. Now, we know that happens. I mean, we can experimentally demonstrate that versus experimentally demonstrating that these particles are so small that they don't collide into each other, right? And see, that's something we can't experimentally demonstrate. We don't see that. So in the being able to explain, you're trying to explain empirical results here, right? So explain non-collisions. I would say that the wave explanation clearly explains that empirical result. I would say the particle conception clearly does not explain that result without going into some really, really far-fetched explanations. So that is a very, very significant difference between those two theories as far as its ability to explain empirical results. And, both of these theories, would predict certain experimental results. So if in fact light were these particle-like clumps, then that would, a natural direct prediction would be that you could detect some collision of these particles. Now, it's possible we just haven't made a sensitive enough experiment to do that. And if you did, and then you could see that there is actual interference coming from different angles, then we would have to change the set of check marks here, and that Garrys explanation would explain it, and my explanation as wave just wouldn't work, right? But I would say that the current experiments that we have would suggest that we're dealing with a wave, since they don't collide into each other. I'm also reminded that if you can have two waves head straight at each other, and they will literally, just like a single wave, they come after each other, and they will rise up, and then they'll just pass right by each other, right? And once again, that's in an empirical, observed property of waves, and that they just simply pass straight through each other, basically don't see each other at all. And that's another huge objection that I have to any kind of idea that, particles, and things which, like this Lego brick, are in any way composed of anything that could be like a wave. Because if it were, then my white brick should just pass right through my red brick, but they do not. When a white brick hits the red brick, they come to a stop. Okay? They do not merge into each other. They appear to be solidly contain something which occupies fixed space, which prevents two of these from occupying the same space at the same time. Versus waves, which, like I explained, you have the two waves going different directions. Many waves can occupy the same space at the same time. They, in fact, really don't see each other because the particle itself can move around in any direction to host the waves coming in from any direction at multiple times. So I would say waves are still the superior explanation for that. So another thing that you have to explain is interference, okay? Now, while we don't see light coming in at different angles interfering with each other, what we do see is that if you have two light beams, which are basically parallel, or you shine light through two slits, you get two very narrow beams of light. What we do see are what are known as interference patterns, where if you put a screen behind that, then you can see these bands of light and dark and light and dark and light and dark. So the question is, what is going on there? Now, that particular phenomenon is basically impossible to explain by light being, say, individual photons. If light were individual photons, then the light coming out of those slits should be evenly distributed, and you should just see like two bright spots behind each of the light sources. That would be the prediction of a clump-like explanation for light. But we don't see that. Now, to a certain extent, you do have to set up the experiment the correct way. You can't always see this. But aside from that, assuming the experiment is set up correctly, is that when you set up these experiments, you see this band of bright and dark and bright and dark, and the bright and darkness depend upon the frequency of the light that's coming through it and the width of the slots, etc., and things like that. So once again, this is another empirically observed experiment that anyone who has a theory of light is going to have to be able to explain, okay? So I don't know what Garry's explanation would be for how these interference effects occur with light as being these individual clumps, as he so says. I mean, why would there be these bands of dark and light if that were in fact the case? And why would it depend upon the spacing of the clumps to determine, the spacing of those interference patterns? Now, if we were to think of light as a wave, then we also know from, for example, the interaction in wave pools, that when you do that, then we know that the waves can either add or cancel. So the waves peak and troughs add up such that when they hit a particular barrier, if the peak and the trough are lining up, those cancel, meaning that there's no change in the height of the water at that point, leaving what are essentially a pattern of high intensity, zero intensity, high intensity, zero intensity, high intensity. So that is well explained easily and empirically by wave theory. So once again, on our list of things that can be explained, I would have to give an X for, draft science, Garrys clump theory, and say that interference is far better explained by a wave type explanation. And this is also, it is kind of still subjective. Garry could probably come up with some explanation for how interference happens, but it would probably once again be a fanciful explanation that requires us to probably ignore logic in some sense. Because as dissidents, we can always explain pretty much anything. So Garry could come up with an explanation saying, well, interference happens as a matter of the size of the clump, and those clumps, generally speaking, are being directed only to certain areas of the screen back there, and things like that. I mean, I've explained some kinds of interference patterns like that myself. For example, they do have experiments where they take electrons, which I would accept are absolutely particles. And they seem to do these experiments which show that interference patterns will develop in those experiments as well. Now, first of all, this is like they call a double slit experiment with electrons, and until actually the 1970s, it had never actually been performed or demonstrated. So everyone was believing that the double slit experiment would work with electrons, having never actually had an experiment that actually does that, right? But I think they did actually demonstrate that. So, so Garry could possibly say that, well, we've demonstrated interference patterns with electrons, and those are definitely clumps. So he could probably claim that that's the same thing that's happening. And maybe that's true. Although the wave explanation is probably still by far the simpler explanation, and it's still not quite clear how the electrons are actually forming these patterns. Now, me personally, I think it's a matter that space is quantized, and when you have a particle that's deflecting through a slot, it has the opportunity to interact with the sides of the slot, because the interference pattern depends heavily upon how deep the slot is and how narrow the slot is. And I'm feeling that what's going on really here is that the electrons are interacting with the edges of the slot. It's like if you have a hallway and you're throwing basketballs down the hallway that's leading into the open gym, that the basketballs are occasionally hitting the edge of the opening door and being deflected off into different directions. So if the ball never hits the door, it goes straight. But if it hits the side of the doors, then they'll hit the side of the door and get to hit off in some random direction. But in the case when you're dealing with space at that small a scale, that space is like a piece of graph paper, and the ball cannot be deflected in just any arbitrary direction. When the ball deflects, it still has to occupy one of these square areas that might exist around the edge. So so I'm going to draw that picture there. So there's the edge of the slot of the slit there, and in the background we have what is basically the matrix of space, and that space is quantized. So what I'm saying, the ball can be here, the ball can go there, or it could go here. It could go in one of those 3 possible x's, and then after it gets deflected, it could possibly go here or here or here, like that, but it can't go arbitrarily. And eventually, when they hit the end of a target, the bright spots are because there are literally more electrons hitting the dark stripe that you're seeing, right? Now, it's not like it doesn't hit. The other places don't get hit. They do get hit, but there are areas where there might be more electrons hitting the screen than other places. And that does not due to a wave interference phenomenon. It's brighter because there are just literally more electrons hitting that one spot. But so I digress, and if Gary wants to take an explanation like that, he can. But once again, explanations like this would be a matter of speculation. So, and not something that has ever been clearly demonstrated. Which, once again, I would say still means that this chart is still valid, that the simpler explanation that fits the facts of the empirical experiments are better explained by wave phenomenon rather than photon phenomenon. Now, another area that we need to explore is whether this provides a complete explanation. And I would say completeness in the sense that you don't have to say appeal to like God or something like that, right? You don't have to appeal to your postulates. And that is something that that Gary would say is a requirement. I mean, at some point, you just have to say that the light wave does that because it just does. That's what light waves do, or light plumps do. And the other question is, if light is a clump, then what is that exactly, right? Once again, you either have to appeal to religion, which is to say, well, they were just created that way, that's what they are, or you can have a mechanical explanation, which does not need to appeal to higher beings, but just needs to appeal to things like Newtonian physics. Let's see, we've got a few comments here. So we've got Stefan and Cornelius and Ian. So welcome to the show here. Let's see here. So Ian, you say you can't enter StreamYard. You should be able to do that if you are going into the live.naturalphilosophy.org. Now, this morning, unlike all the previous mornings, I was able to set up, well, David set up the conference. And I just had to enter it. Now, it's possible that I messed up and I don't, and that this link, live.naturalphilosophy.org, doesn't work. So if that doesn't work, and that's the reason why there's only me in the live conference here, then let me know, and let me know what kind of problem you're having getting into here. So I'm gonna, I want to know if you're not able to enter the live.naturalphilosophy.org. Now, Cornelius, he has this comment here, which is interesting. So, it says, mass-bearing particles can be explained as focused longitudinal wave patterns. So, I'm going to respond to that, and I'm going to say, no, they can't be explained as longitudinal wave patterns. Once again, the main problem being that if they were longitudinal wave patterns, then what would make them focused? Okay, so we're presuming the same physics exists everywhere, and that and we have to be careful about definitions, and we're talking about waves. Okay, once again, so waves have to be anything where you get something that happens at regular frequency. So waves must, I think, have frequency in order to be a wave, or at least have a width, because I suppose you could have a single wavelet, and so that wouldn't necessarily have a frequency, but it could still be said to have a wavelength. And then if you put a whole bunch of them together, then that could still be said to have a frequency. So the main problem here, Cornelius, and so if you want to talk about this, please come into the live room and we can discuss this, because it's a very interesting question. So, which is that if you have a wave, then how can it be focused? It focused in what way? Focused in such a way that it produces something like tangible matter, like this red brick, okay? So if you're going to have a theory that says that this thing can be explained as a focused longitudinal wave pattern, you just can't say that. That doesn't explain anything, right? That doesn't explain how it's focused. How is it different from the sound wave? What makes it not just spread out? Because this is the main problem with waves, is that they don't stay in one place. Like this brick. Okay, this brick stays in one place and it'll stay there forever. It doesn't. If it were a wave, then it would immediately expand out, because that's what waves do. So what you're suggesting is that they don't do that. That somehow the wave somehow stays within the boundaries of this thing that I'm holding, right? And that gets into the possible ideas I've heard about standing waves. That this can be, the focus can be explained as being a standing wave somehow. Like if you have a violin string and you pluck it, then you can see the wave go back and forth. But the problem is, in order to have a standing wave, it has something to stand in, which in the case of a violin would be the bridge up to where the tuners are, right? So you have a string, it can go back and forth. There's something that's physically bounding the wave. Or you can have like a speaker, and if you just generate a single tone, then if you look at the wave that's going out, that could also be considered a standing wave, but it still has to be anchored on one end by the generator, and in that case the wave just goes off to infinity, right? And it's completely unbounded, and there's nothing between the speaker and infinity to suggest that there's like a particle back there. So my extremely bright grow lights have just gone on, so let me turn that off. Okay, so I am getting a comment that it said that the broadcast ended. Well, I did do a short test trial of this conference, and I had to end that, so maybe that's the problem. Let me try it myself. I'm going to go to I'm going to go live.naturalphilosophy.org and see what errors I get there. Because I'd like you guys to be on the program here. You're probably getting tired of hearing me talk here. So I'm going to enter in as Franklin who too. Now wait a minute. Now you guys are over here in the second one. So it says ended 154.53, and I can see Ian here. Yes. So that's weird. So let's see here. You guys are out in this secondary thing here, but I don't see you in the broadcast that I am in. So that's weird. So yeah, we have got some issue with let's see here. This broadcast is ended. So why is it when you guys enter here? Yeah, so you have to give me a minute here to try and figure out what's going on here. In that you are connected to an ended broadcast and you cannot get into my actual live broadcast here. Let's see, I may have to get out of this or something. So let's see here, if I add people here, if I add Ian here, but we got massive echoes going on here. Turn to dashboard. I am not quite sure why it's doing that. Well, what I may try and do is I'm going to end this broadcast again, and let's see if we can restart it, and then see whether people can enter. Because I don't see any other thing that I can do here. But let's see. Before I do that, though, let me address these comments here. Before we do that, since we'll lose that, we have this comment here. It says, Andre Assis, member, shows that forces in electrodynamics are not well understood. Can you speak to that? Well, I think that would be the whole thing, that none of the electrodynamic forces are understood at all. I mean, not well, but we don't have any explanation for what charge is, or how the magnetic field propagates, or how gravity works. And I would say, like, if any mainstream scientists were honest about this particular question, like what is charge, the honest answer is we don't know. And that seems, kind of funny that we base all of our science off of these forces, but yet we have really zero understanding of what they are. And I would say that, that's one reason why that is a lot of the topic of discussion here in the science chats, because it is an open question. So we're trying to determine, the basics. Like earlier this morning, I was talking about what is the nature of, say, light, right? Even that does not come with a accepted mainstream explanation for what that is. So I always doubt, how much can we claim to know about science and physics if we cannot explain how charge works, or what is it, or how magnetic fields work, or even what gravity is, and what is the relationship between all these forces, right? So I would say we don't. I would say that it's a symptom that we massively misunderstand something about the world that is preventing us from coming up with any reasonable explanation for what these forces are. So, as a dissident, one of us is going to figure out, for example, what charge actually is. And then that will make physics, that will be an advance in physics that will allow us to finally manipulate these forces. So, for example, if we knew what charge was, then perhaps we could create a region of extremely high charge and manipulate the world using that. Now, some people like Bob Lazar believe that alien technology has in fact been able to do that. That they know what charge is, and they, virtually create a charge gun, so that you can create like a tremendous, positive charge from something the size of your cell phone or something like that. And when you do that, you can, propel your spaceships or create weapons that can just like drill a hole into some wall, 10 miles away. Or you can actually distort space or do something like that. But if we understood how charge worked, then as engineers, we could then start to manipulate it. But as it stands now, we don't know. You cannot manipulate something you don't know how it works, right? So thank you for that question here. So Michael Antesky says, wave peak is from cascade of ether units transiting to quantum units after outside energy stimulation. Wave trough is from dieback of energized ether units. So Michael, do you hear what you're saying here? It sounds a little bit, I'd say my criticism here is that it sounds a lot like word salad. That there are a lot of words here, but not a lot of explanation of what these are. Because what do you mean by cascade of ether units? What would that mean? And then transiting to quantum units. Well, what does that mean? So you have a cascade of ether units, and I know your Ethernet is just like these little, they're, linked together, but fundamentally they're something. Transitioning to quantum units, and what is that? After outside energy stimulation, well, what's that? Wave trough is from dieback of energized ether units. So I'm just saying that this means really nothing, because we don't know what your cascade means, we don't know what your transiting quantum units means, we don't know what your energy means, and wave trough is from dieback of energized ether units. That's very complicated explanation. Versus, I would say, what is the wave peak? Okay, well, a wave peak is the period of time when your medium is concentrated at its highest pressure. So if I'm speaking, and I'm making a wave, the wave peak would correspond to, like if I have a microphone, when it's being impacted enough to depress the diaphragm of the microphone. And then the wave minimum is when it springs back, right? So that is an actual explanation for what wave peak is. That doesn't involve the words cascade, transitioning, quantum, energy, or dieback, or energize. All that particular explanation requires is that you have a medium that can have different concentrations, and the wave peak is when the medium has highest density versus lowest density, right? So that, I would say, is just an example of what would be a simpler explanation here. And we have Bill Lucas, yes, and his version of electrodynamic shows what charge is. Actually, I'm not quite sure, because the electrodynamic field in your theory is fundamental. So basically, you get to not explain what charge is. You just say that it basically exists. But if we get the conference working, then we can talk about that. So elemental units are building blocks of larger energy units. Well, I think everyone would agree with that, except that, I would say the ether units have to be building blocks of not larger energy units, because what is an energy unit? Once again, we're using terms that generally speaking don't make any sense, because you generally speaking can't hold energy in your hand. Energy is like matter in motion. So energy, if to give this block energy, I can move it around like that. So this block has more energy. That's not something I can hold in my hand. But I would say that ether units are building blocks of larger bits of matter, I would say. And I would disagree that ether units are building blocks of larger energy units. Let's see here. So thinking in terms of ether units could be useful, especially knowing that the medium doesn't exist as shown by experiments in light and trust the key. Yes, I would agree. I mean, curiously enough, there was a recent article in email chains saying that, some mainstream scientists are believing that we do need to bring back the ether, in fact, in order to explain things, even in relativity and things like that. So we may be getting to the point where other people, even mainstream, are willing to consider that this ether might actually exist. And I particularly think that if we could determine exactly what that ether is, then we could actually find it. This is the main problem with ether, is that if you don't know what it is, you can't find it, right? So that ether is either one of two things. It's either made out of things we know about, or it's made out of some new other particle that we haven't discovered, right? Like the Higgs boson. Maybe the ether is made out of the Higgs boson, but no one's ever... well, I suppose they think they found one at CERN, but apparently, it's nothing you can hold in your hand. Or it could be something that we do know about, which, my own personal pet theories on this say that ether is actually made out of a matrix of positrons, electrons. It's referred to as, PE, positon electron space. And if that were true, then experimentally we ought to be able to find it. We ought to be able to tear it apart. We ought to be able to put it together. We ought to be able to manipulate it, create a wind or something with it. That's a possibility. So, and Bill Lucas does bring up that he has measured the tensile strength of the electric field and showed that it is uncuttable. So, but I would say that we can't exactly rely on anything that any one person says. William Hooper is just like any one of us, and we could always come up with conclusions which may or may not be correct. So things like tensile strength, what exactly does that mean? I think that means that if I have, say a proton and an electron, that if I move them apart, there is some strength in there. I guess it would be, so because they're attracting each other, right? So that there's something there, and that it's uncuttable, and I don't know what it would mean to cut the electromagnetic field anyways. So that's the comment that income paradigms has, which is, what is uncuttable? What would it mean to have a uncuttable tensile strength between the electric field between particles? I mean, I suppose, first of all, to have an electric field, you must have a particle, and there must be a charge emanating out of that particle. And then, you know, you have your opposite particle here, and we know that there's always a attraction between these two. And so is by uncuttable that you mean that it can't be shielded? I mean, it's basically the concept of cuttability ultimately depends on there being some actual material material between them, you know, like this piece of paper here. So this piece of paper here has tensile strength, and it is in fact cuttable, right? So, what does that mean in terms of electrodynamic force? I don't know, because all we know about the electrodynamic field is it exists between two charged particles and through what seems to be empty space. And what would cuttable mean? And Stefan has got something in here in foreign language. Sorry, I don't understand that. And says, do you know what word measurements means? Well, I think we all know what measurements mean. It means that we set a standard for something like length, and then we get like a ruler here. Measurements means we go and we determine what we are measuring here. So I would say that's like 4 inches by my ruler there, and that's what we mean by measurements. So I'm kind of wondering, do you need something more complicated than that? Measurements is what we measure using our instruments. That's why it's called measure, right? So now that we've gone through the comments, so I'm going to try and end the broadcast, restart the talk from scratch, and let's see whether you guys can re-enter. Okay, so let's try this. This may take a minute or two. So I'm going to end the broadcast here.